Okay, so now based on all this, let's make a prediction. Okay, so the unseen example that we have, is, okay, let's say it is raining and it is hot outside, the humidity is high, but it is not windy. Okay, so given this x vector, given these features, what is the prediction whether we'll go out to play tennis or will not, or whether that person will go out to play tennis or not? So what are we going to compare? We are going to compare the probability of p given x with probability of n given x. Now this is equal to probability of x given p multiplied by probability of p, and this is again divided by probability of x. Okay, divided by probability of x, and this will be probability of x given n multiplied by probability of n divided by the probability of x again. But because the denominator in both the places is probability of x, we need not actually compare. So our comparison is between probability of x given p multiplied by p and probability of x given n into n. Now what is the probability of x given p multiplied by probability of p? So probability of x given p, so what all is there in probability of x? X comprises of rain, hot, high and false. So probability of rain multiplied by p, probability of rain given p multiplied by probability of hot temperature given p multiplied by probability of high humidity given p multiplied by the probability of no wind given p. This is by our naive assumption of the naive Bayes classifier, that all these attributes, that it being rainy outside and the humidity and the temperature being hot and the humidity being high and it not being windy, all of these are totally independent of each other, which is not true in real world. Like for example, rain and humidity you can clearly correlate, but then this is the naivety of this algorithm, naive assumption, and it works sufficiently well for our calculation purpose, so we'll go ahead with it. And probability of p. Okay, so now probability of rain given p, where will I find this? Rain, this is in the outlook table. So probability of rain given p is 3 by 9. Then the probability of hot given p, so probability of hot, I'll find this in temperature. So probability of hot temperature given p, so this I will find from that table as 2 by 9. Then third is high humidity given p, so this value I'm talking about, so this is again 3 by 9. Okay, and finally windy being false. Okay, so false given p, so this is the value 6 by 9 that I have found from the table. And finally probability of p, because there are 9 p's out of 14, so this is 9 by 14. Okay, and if you calculate, this comes out to be 0.01058. Okay, now let's calculate the probability of x given n into probability of n. Okay. Let's just go over it. Just a bit. Okay. You know what? Let's calculate it on the upside, above, over here. So probability of probability of x given n multiplied by probability of n is equal to probability of rain given n into probability of hot given n into probability of high humidity given n into probability of no wind given n. Okay, and again finally multiplied by probability of n. Okay, so this is equal to probability of rain and n. So this is 2 by 5. Probability of hot and n. This is again 2 by 5. Then probability of high and n. This is 4 by 5. And probability of false and n. This is also 2 by 5. Okay. And all of this multiplied by 5 out of 14, which is the probability of n. Okay, and if you calculate this comes out to be 0.0182. Okay, so now let's compare the two values that we have. Okay, so this probability came out to be so this probability value came out to be 0.01058, and this probability value, okay, this one came out to be 0.0182. So clearly this is the greater one. So what we'll say, the probability that the label is n given this x value is higher, therefore the prediction is n, that is the person will not go out to play tennis. So that's it for the Bayes classifier, naive Bayes classifier. If you have any questions, any doubts, do post them in the comments below. Thanks for watching.